Alright, welcome back to the videos. This is section 3-4, direct variation. There's a couple vocab words here for a new equation, but it's not really a new idea. It's a kind of a variation of linear equations. So go ahead and copy this vocab word down. A direct variation is any equation of the form y equals kx. So in here we have x is your input variable, as it always is, right? And y is your output variable, as it always is. And then k is defined right here. It's its own vocabulary word, actually. The k value in this equation is called the constant of proportionality, or the constant of variation. So, as x changes, y will also change, and k tells you the relationship between that change. So, if you have a linear equation, k is representing the slope of the line. So we'll look at some graphs to represent these functions, as well as some examples. So, problem-solving tips. The first thing you need to do for any problem is decide, if it's a word problem in particular, which quantity y will stand for and which quantity x will stand for. So, for example, if you're looking at the length of a shadow of a tree as a function of how tall the tree is, you might choose x to represent the length of the shadow and y to represent the height of the tree. It doesn't actually matter which one you pick. X or y could be either variable, but you need to clearly pick and identify and label. So at the start of the problem, you're going to say x equals and what it is. So like height of tree, for example. And then y, you don't have to write this down, obviously, shadow. But you want to clearly identify at the beginning of your problem what your x and y are standing for. That's very, very important. So the idea with this kind of thing is when one variable goes up or down, the other goes up or down by the same ratio. That's because of our equation, y equals kx. If we double this side of the equation, we have to also double this side. So if x increases or decreases by a certain ratio, key here is ratio, then y will also increase or decrease by that same ratio. If I add 5 to x, I can't conclude that I just add 5 to y, because that's not a ratio. Adding and subtracting, not a ratio. Multiply and divide is a ratio. Another property is if you were to graph a direct variation problem, y equals kx, it's always a straight line through the origin. So every graph goes through this point and will be a straight line. And again, I already said before, the slope of this line is going to be the constant of variation k. A few more problem-solving tips, and then we'll do the examples. There are a couple different ways to solve equations. The first is to use the given information to find k. So you start with y equals kx. If you know the y and you know the x, you can find k, okay? Once you know k, find k, and k is constant, which means once you know the value of k, you can use that value in any other questions about the same problem. So the problems usually start by saying, when x is this, y is this. So that's enough information to find k, and then they'll ask you questions about other situations involving those variables. The one-step solution is to set up a ratio using the fact that k is constant. So if we start with this equation, y equals kx, and we solve for k, we divide both sides by x, we have k equals y over x, which is constant. So what that means is y at the beginning over x at the beginning must equal y at the end over x at the end. Okay, and so here's your shortcut. You only want to use this for direct variation. If you try to use it for anything else, it's not going to work. But for direct variation, you don't actually have to find the value of k to solve the problem. You could use this shortcut, whereas the two-step solution is to first find k and then use k to find the answer. Last thing is always check your answer for common sense. If x went up, y has to go up. If x goes down, y has to go down. So make sure that that's the case. All right, let's do a couple of examples. Find x when y is 2 if you know x equals 5 when y equals 8. This two-step solution is to find k. So y equals kx, we start by writing the direct variation equation. We plug in our numbers. 8 equals k times 5. Divide both sides by 5. So we know that k is 8/5. We can now use this to find other information. Now it says, so we write the equation again, find x when y is 2. So we plug in a 2 right here. K, I found out, is 8/5. and I'm looking to find x. So to solve this equation, I have to multiply both sides by 5/8. Right? Here the 5's cancel, the 8's cancel, and I have that 10 over 8, that's 5 times 2 is 10, over 8. You can think of this as a 2 over 1 equals x, and I can reduce 10 over 8 to 5 over 4. So 2 steps to get my answer. First, solve for k, then use the value of k in the equation to find the other unknown. The shortcut is y2 over x2 equals y1 over x1. So I can plug everything in. The first case is going to be my y1. So here we go. 8 over 5 equals y2 is 2 over x. It doesn't matter whether you call this 2 or 1 and this 2 or 1 because they're equal, they can change sides. To solve this, I'll cross multiply. So 8 times x equals 5 times 2, which is 10. Divide by 8, divide by 8, and x equals, cancel. 10 over 8 reduces again to 5/4, so of course you get the same answer. So 2-step solution or 1-step shortcut, they both work, but in both cases you obviously need to show what equation you're using, then plug in your numbers, then get your answer. Okay, one more example. You drive your car 40 miles in 35 minutes. How far can you drive in 1 hour? The 2-step solution is to start by writing equation y equals kx. Now we need to pick the variables and identify them because this is actually a word problem, right? So I'm going to let this one here be distance, and this one here be time. The more time I drive, the farther I will go. So I can solve for k by plugging in here 40 miles equals k times 35 minutes. Okay, I can solve for k by dividing by 35. And this was miles, and this was minutes. So k equals 40 over 35 reduces to 8/7. Divide both by 5. Miles per minute. So that's part 1, get my k value. Then part 2, how far can I drive my car in an hour? Well, we need to do, this is 60 minutes, because our other one is in minutes, so we need to compare minutes to minutes. We can't compare minutes to hours. So we write the equation again, y equals kx. So I know that my time is 60 minutes, and I know that time is my x variable, and I'm asking how far I can go, which is the distance, which is my y. So I don't know the y value, so I leave that as a variable. K I found out before as 8/7 miles per minute multiplied by x, which is 60 minutes. Okay, minutes will cancel with minutes, and I have 8/7 times 60, and if you grab a calculator, which I don't seem to have, oh, here's one. So we can do 8/7 times 60, then we get y equals 68.6 miles. Okay, so we can solve it and get the distance, and it makes sense. If you go 40 miles in a little over half an hour, you could go 68 miles in 1 hour. So that's how fast you're going, 68 miles in 1 hour. The shortcut, y1 over x1 equals y2 over x2. Plug in our stuff, so distance, 40 miles over 35 minutes equals x distance over 60 minutes. Again, you need to line it up so you have your minutes both in the bottom and your miles both in the top. Solve for x, cross multiply, 40 times 60 equals 35 times x. Divide by 35, or better yet, because x is right here, all I really have to do is multiply by 60, which means the 60 will go over here, and leave the 35 down there. In any event, if you multiply 40 times 60 and you divide by 35, I'll check it, just to make sure. It's good to double check. 40 times 60 divided by 35 on my calculator. And of course I got the same answer, 68.6 miles. So there's two ways you can do these. It doesn't matter to me which one you do. The only thing is you have to make sure that when you're doing this shortcut, you get the pieces lined up correctly. If you have miles over minutes on this side, you need to have miles over minutes on this side. You don't want to accidentally flip one of the sides over. Okay, that's it for these kind of direct variation examples. See you in class.